Okay, good afternoon, everybody. This is Peter Cooper again. This is a webinar on dealing with one of the WebBlast tabular formats. If you have a question during the webinar, please type it in the questions pod. Ronna Morris from the service desk, who works with me, will be here to sort of field some of those questions. We will deal with some substantial ones at the end if there's time. If there's not time, we'll definitely answer them in a Q&A document. And all that stuff is going to be linked to our webinars and courses page. There's also a compressed link to the materials directory on the FTP site. It's going to have the slides. It's going to have some text documents that has some of the little, I hate to call them scripts, but little command line things that I've made for this webinar and other things, including the Q&A document. So Rana can probably send that out to you via the chat pod in a few moments. Okay, so let's get started with the content. So we're going to talk about using the WebBlast tabular format. By the way, my email address is on there. If you have direct questions about this material, you can write to me, peter.cooper@nih.gov. We'll see at the end that if you want questions about the webinar, we'll save those for a different email address. So what we're going to do today is learn how to download the hit table from your BLAST results. And we're going to use Unix Linux tools to process the tabular output. And we're also going to use EDirect to get additional information on the database matches. We'll talk more about what I mean by that in a second. And we'll combine the new information back into a tabular format so you can basically add columns to the tab format to get more information. And then we'll just show you at the end, suppose you had a bunch of sequences that are in your BLAST output and you want to download them. I'll show you how to do that with the EDirect program eFetch. Okay, so we know that many people are interested in saving BLAST results. And so in the old days, I know that in many cases people would literally print out the pairwise format from the web page and save it in a notebook. This is no longer an option, and it's really not a good idea anyway, but it's useful to save this stuff in some format that you can archive it. There are several options here. The one that we're going to focus on today is a real nice option because it's compact. It's called the hit table format. It does contain abbreviated information. I'll talk more about how it's abbreviated in a moment. And of course, there are structured outputs. That's for a more advanced audience. And if you want to deal with the structured output and you have ways of dealing with it, that's great. XML is a good choice. And actually, there is a webinar on the YouTube channel on how to use the EDirect program extract to parse that output. But we're going to talk today about the hit table format and how to deal with it. So basically what you get with the hit table text, which is the one I'm going to talk about, there is a CSV, comma separated variable format. We won't deal with that one. It's the same stuff. It just doesn't have any headers on it, so it doesn't have your columns labeled for you. So many people would probably prefer this one. The advantage of this format, and this is what a lot of people do with this, it's easily opened and manipulated with spreadsheet software like Excel. There may be other spreadsheet softwares. I'm not aware of them. It's a compact file. It doesn't take up a whole lot of room. The problem, of course, is that it's abbreviated. It doesn't directly contain some useful information. For example, it doesn't have sequence titles, it doesn't have the taxonomy information, and it doesn't have links, for example, to get the match sequences. And we'll see how to add all that stuff in a few minutes. So the way we're going to do that is we're going to use simple Unix Linux command line tools that are good for working with text files and columns. There's a whole ton of these. The ones we're going to use today are cut and paste and sort, and those are all the names of commands you can run on the command line. And then there's awk, which is really a programming language, and it's a world unto itself. It's sort of the ancestor of languages like Perl. But we're going to use it in a very limited way today. Just right now, if you are an advanced scripter and you know a heck of a lot about Unix, this probably isn't for you. You know more about this than I do. But this is for people who have sort of modest needs to deal with this. And so we'll show you some simple ways to do it. We're going to also use EDirect, the programs eFetch, ePost, eLinked, and extract to work with this. So you may say to yourself, what if I don't have a Unix Linux machine? Well, that's okay. If you have a Windows machine, you can use the application Cygwin, which you can easily get from the web, download and install. And it's basically a Linux-like environment, and you can work with all these programs there. On Mac, you do have a Unix Linux system, and you can get to it from the terminal application. So this could take a moment to mention EDirect. This is a command line version of the e-utilities, and we have given webinars about this, and there's lots of good information available in the documentation there in the bookshelf. And we're going to use that, and it's installed on our machines here at NCBI. You could easily install it on your Windows or Mac or Linux machine. A number of different programs in there. I won't spend much time talking about them. We'll just learn how to use them briefly. Okay. And basically, here are the different programs. They all interact with something called the history server at NCBI. You post some IDs up there. Those IDs could come from a search. Then you retrieve those IDs in whatever format you want. Most commonly, that retrieval is in the form of an XML record, and you use extract to parse out things from that XML. We're going to do that today. There is a webinar on this that you can see on our YouTube channel as well. So a typical EDirect process would be something like this. You have, you're starting with IDs. Now you could get them from the program eSearch. We won't talk about eSearch today, but say we have some IDs. We put them into eFetch, and we pipe that's the Unix pipe, to the other program, extract, and we're going to try to get some information out of that using this parser extract. If we have lots of IDs, we might want to use ePost to put them up into the history server, retrieve them, and then use extract to parse them out. Likewise, we could get the links from those. Say we want to have our protein records linked to PubMed. We could follow those links and get the information we want from those PubMed records using extract after we fetch them. When you extend this whole process to dealing with BLAST output, you're basically going to take the tab delimited output that we have, and we're going to do things with it with awk, cut, paste, and sort. And we're going to pass that to EDirect. We're going to take that data that we get back from EDirect and put it back into the tabular output using those Unix command line programs, awk, cut, paste, and sort, and so on. Here's a complicated example that I hope to get to today, where we're basically going to take our BLAST output. We're going to get some information out of it using awk. We're going to post those IDs that we get using awk to eFetch. We're going to pull them down, get some information out of them with extract. We're going to sort that information by a particular column in the output. We're going to take that file actually and paste an output stream into it to get a much larger tab delimited file, and use cut to get rid of an extra column that's in there. So that's sort of a workflow that you could do that uses a bunch of different tools. And there are the EDirect programs here sort of at the beginning of that with a bunch of post-processing using Unix command line tools. So here's what we're going to do. We're going to use awk to add links from BLAST matches to protein records at NCBI. Then we're going to do some stuff with EDirect. We're going to use ePost, eFetch, and extract to get sequence titles, taxonomy IDs. We're going to use the Unix sort, paste, and cut to process this output. We're going to take a brief look at some other applications so we could get some publications, we could get some taxonomy information from our BLAST output. And we'll use eFetch and sequence formats to download the FASTA proteins. If time permits, I don't know if it will, I'll just point out to you the nucleotide coding region output that you can get from the FASTA CDS NA. So let's go ahead and get started on those. And if you want to follow along, you can try, or if you want to see what I'm doing, there are a number of different files on the FTP site that are in that link. But you don't need to do that. I'm just going to be playing along with that, and you can follow. What I'm going to do is I'm going to show you a lot of the times we're going to be working on this command line here. This is a terminal window that goes into one of the Linux servers at NCBI. And I'll copy paste, because typing them would take too long, some commands that we're going to use today to do the things that we talked about. So let me just I'm going to need a little cheat sheet here that I'm going to copy paste from. And that's this file, which is the command only text file that's up there on the FTP site. And it has the basic commands that I'm going to type in. Now, so the BLAST search that I'm going to do is I use the human protein creatine kinase B against Firmicutes bacteria against the NR database. This is a search that's kind of arbitrary, but useful in a way because it shows it's got a small set output, makes it easier to work with. And actually, I have that up here in a web browser. What I've done already is I've expanded the download options here, but just to say, here's my output. I've got 20 hits. You're probably all familiar with this. And I want to download this. I can simply open this here, pick the one that I want. So I want to pick the hit table text. I can download that and I can put it here. I've already saved it as this CKB firmacute/p.text, and I can say that I've already got it there, so I won't do that, and I'm going to be working in this directory on one of our machines. Okay. So first thing let's do, I'm going to go over to the command prompt now. Let's go ahead and take a look at what this looks like. So I'm just going to use a real simple Unix command to do that. And actually, just so I don't have to type because I'm a poor typist, I'll go ahead and just copy paste this. So that's just going to dump that to the screen. Copy that, paste it in. And in case it gets long, I'm just going to pipe it into the Unix program more. So here is what the hit table looks like. It's got a big header at the top telling you all the details of my search. Then there tells you what the fields are. Those are the column headers. Notice that there are some things we have to pay attention to. The column headers are separated by commas. We're not going to deal with that right now. We're just going to realize that we can deal with that if we want to. These columns are separated by a tab character, and that's the character we're going to be using to sort of parse this. And these are the proteins that we matched. Those are the things that are probably of most interest to us. Now, if I wanted to, I could open this in Excel, and I have already done that. It just opens directly. You just have to tell it about those commas. So you get your column headers here. And here I've even added a column of the links, and we'll show you how to do that in a moment. So this is the same file that I just opened with Excel. So we now have this, and we know I've already enhanced it by adding the link, and I'll show you how to get those links in just a moment. Okay, so the first thing we want to be able to do is to get those that column that has the accession numbers for the proteins out of there. So we're going to use awk, and I don't really have time to talk a whole lot about awk, but we'll take a quick look at this command line and tell you what it does. Okay, so this is the awk command line we're going to use to get the column 2. So this is awk. This is a command line processor here, so it says separator of the fields is a tab character. And this says let's only look at things that have more than one field in them. So that's going to be all the things that have the rows. It's going to avoid the headers and things like that. And this just says print the second column. And this is the file we're going to use, and I'll just pipe that into head. Actually, I don't have to. It's only 20 IDs. So we'll do that. And there they are. So that's the accession.version of all the 20 proteins that we matched in the database. Now, I know I'm going fast, and you can't copy all this stuff down. This is all in that text file. It's on the FTP site. All these command lines are. And that's the one that I'm looking at right here. I'm just going to clear my screen. So if you want to retrieve a protein from Entree, all you have to do is use this base URL, which says, NCBI, then protein, then the accession number. So if I do that, there it is right there. Here's my protein. Well, it might be handy to have that as a set of links in the file. So what I can do is use awk again in a very sort of simple way. Basically, it will print that as part of the print statement here. Then it will print $2, which is the second column. And then I will have basically a set of links that I could just copy paste into my Excel file. So this is just basically a print statement, since I know the base URL is consistent. And then there you have it. You could simply copy paste that if you want to. If you wanted to enhance this a little bit, suppose you wanted to make sure that these links retrieve the FASTA format. That's easy enough. All you have to do is realize that there's a simple URL for doing that. And that just basically adds this and report FASTA to the end of that. So that's just a little bit of an embellishment, but it's something that you might want to be able to do. Again, you could just copy paste that into your file. If you want, you can use a more sophisticated thing and basically use awk to create a file that has this as the last column. And that command line is right here. And I won't bother to do that one for you, but basically that just says print the first line in the file and then add to the end of it a column that contains this URL. Okay. So that's how we could do a simple thing of enhancing our output with links. The other thing we want to be able to do is to get some more information about the sequences. And so we're going to use efetch to do that and extract. So let me just go ahead and get one of the proteins from the file. There it is. I'm going to pipe that into more so you can see. This is going to give me the document summary XML. And what I'm going to want to pull out here is, suppose I want to get the title. That would be useful to get. I could also get, for example, the taxonomy ID out of here. Okay, there's the tax ID. And if I needed to get it, I could get the accession.version, which is down here at the bottom. And so you can read how to do that kind of stuff in EDirect, but it's basically pretty straightforward. Just set up a command line to do that. And here's one right here. It's going to get me the accession.version, the title, and the tax ID out of that XML. So I've got the title, I've got the accession.version, and I've got this item on the last column here is going to be the tax ID. I could use that later on if I wanted to go into the taxonomy database to get more information. How do I do this for all of my IDs? I need to use ePost. So ePost has a real simple sort of syntax. You can always see the options for any of the EDirect programs by simply typing help at the end. So that's all the things I can do with ePost, but I can take a list of IDs and I can put them in the history and then work on them. So the command line that will do that for you with all of our IDs, it's just taking the exact same awk command that we used before to get those IDs from the file. And then I'm going to parse all this information out using extract. And this is going to probably wrap around the screen, so it might be a little ugly to see in the output, but we'll go ahead and do it. There they all are. Okay, so now I have all this information. I could, as we saw a minute ago, I could paste this into my file, but you might notice something, and that's that these things are in a different order than they are in the Excel file. So what I have to do is to sort these by something. And then I could sort the Excel file in exactly the same way, and then add this back in. So we're just going to use the Unix command sort to do that kind of thing. So the first column there is the accession.version. I can sort by that. At the top of the screen. Put it back in. So I've just piped the output here. So here we're doing the workflow we're talking about. We're starting with a Unix command line tool. We're going into EDirect, and we're finishing with a Unix command line tool sort. So now these are sorted by accession. I need to do this because what I want to do is to go back in and sort the other tabular output by accession so I can get the body of that table to line up. So I can take the exact same command line that I had before and just add sort. But now I'm going to have to sort by the second column because that's where the identifier I'm interested in is. And I can save it if I want to. So I'm just going to save that for us. So I'm going to use the redirection output operator there, the greater than sign, to put that into a file. That didn't take long. The reason is because this was local data that I had. Because notice we're just processing the file. We're not doing anything here. And I can just more that if you want. And now it's sorted by accession in exactly the same way that the output was a minute ago. Now there's a rather long command line, which is the sort of final version of this where I take these two things and paste them together to make this output. You could also just simply take this output right here, copy it. Well, first you want to do is you want to sort your Excel spreadsheet by this column, the accession. Once you do that, you could paste the two files. You could just paste this into Excel to get your additional columns, that first one into Excel. This is what your sorted Excel spreadsheet would look like. I can do that computationally or on the computer by combining a bunch of different things. This will get a little ugly because it's going to be a long table now. So I've added another Unix command at the end of this, and that's the program paste. Paste is going to take this sorted hit table text file, and that little dash there says standard output, because what I'm going to do is I'm going to take this, make a stream here of just retrieving that information that we did a few minutes ago to get the additional information from eFetch. This into more. And now we have, it's kind of funny to watch because it's wrapped around, but notice this is the file, exactly what we talked about doing. The only thing that's a little bit awkward now is that what we're going to have to deal with is the fact that we have two columns of the hit accession number here. That was just used to line the two tables up. You can remove that easily with a command that uses cut. Cut's a thing that works with columns, and I could just tell it, cut this column right here out, and use a switch called complement that says, give me everything except that column, and you would get the table back. Right? That's enough of that kind of stuff. Let's move on to talking about getting sequences, and then we'll finish up. Okay, and the final version of that command is right here in this file on the FTP site. A couple things to mention. There's some command lines that I could use if I wanted to get, links to PubMed for one of the records. And you could do the same kinds of things with this information that we did with the other things. Likewise, there's an example for the taxonomy. So if I want to get the lineage from one of the tax IDs that I had in my table. And so there I've got the complete lineage of one of those tax IDs. And again, I could line that up in exactly the same way that we lined up the other things. So what we want to do now is we're going to use eFetch in a different way, not using XML, but we're going to get the protein sequences down. So to do it with a single record, it's very simple. It's exactly the same command that we had with eFetch before, except this time we're going to get the FASTA format back. There it is. And to get all of them is exactly analogous to what we did before. We're going to use ePost to do that. We could just parse our file as we did before. We're going to post it to protein just like we did before. We're going to eFetch it, and we're going to save it in a file called proteins.faa if you wanted to. What I'll do is just let that go down the screen. So you can get all the protein sequences that way. Okay, and that's basically what I wanted to cover today. There is an infinite number of things that you could do. Certainly there are much more sophisticated things you can do if you want to get into like parsing output. If you really want to parse output, you should probably parse one of the structured formats. But this is a real simple thing. These are simple things you can do with that tab delimited output. Once you have it on your computer and you have these additional tools to work with, you can do pretty much anything you want with it anytime you want to. Okay. So what did we learn how to do today? We learned how to download and process tabular BLAST output using the Unix command line tools, the EDirect suite of programs. This slide is at the end, and you can certainly take a look at this. This is where you can get more information about these BLAST and about EDirect. And let's open it up for a few questions. We're probably going to run overtime, but we'll leave it open for a couple minutes if anybody has a specific question.
User writes in, these tools are awesome, but there's a question about the number. Does NCBI block the request when the number of IDs are very high? Someone has been having an issue with taxonomy.
So the answer to the question is, do we block people? The answer is we do sometimes. But there's another problem that these programs, like eFetch in particular, There are basic limits, physical limits as to the number of IDs that it can process. And so if you're in the areas of hundreds of thousands, your request probably won't work. So, if you're going to do that kind of retrieval, you'll want to work with smaller files. If you do things like submit multiple requests simultaneously where you're hitting the web servers, thousands of times a minute or something like that, yes, we will block you based on the IP, but eFetch will fail with large numbers of IDs.
For a fairly experienced scripter, they have a question: is ePost better than just a bash loop?
I'm not sure I understand what you're trying to say, but ePost is, if you're trying to submit, one of the things that we really don't like people doing, there are many people who do this, they use scripts and they submit IDs one at a time. We don't want you to do that if that's what you mean by a bash loop. What we want you to do is to use ePost and submit the IDs in batches and then get them down that way.
User asks, is there an alternative to EDirect tools to retrieve data from local copies, or are there mirrors of some of the NCBI databases? An alternative to EDirect for retrieval?
So no, there's EDirect is basically, these are just wrappers around our URL API. So they're accessing the Entree system at NCBI, which is not, you can't install that locally. And there are no real mirrors of that system anywhere. I hope that answers the question. I mean, if you have your own local database of things, you would be using some kind of database program like SQL or something like that to access a database. Okay, I think that's all we have time for. If there are questions that we didn't answer that you've sent in the questions pod, we'll certainly answer them in the document that I'm going to produce that has the questions and answers in it. So thanks everybody for coming, and we'll see you next time.